Starting.
This meeting is being recorded.
So I'm starting the recording. Muting everybody. And we're ready to start. So hello, everybody, and thank you for joining. Today, we will speak how to test your React components without testing implementation details to make them really last. But before going to the main topic, I want to introduce you myself. Hello, I'm Alexander Guzman, and I'm a testing enthusiast. Some years ago, I have discovered a secret way how you can use your tests to make your everyday front-end routine much more fun and much more reliable. And my goal is to share this secret gem with everybody to make everybody's development routine much easier, My Israeli journey has started in a small startup called TruckNet here in Eilat, where I do live. And I know that there are some people from TruckNet watching. So hi, hello, everybody. I'm missing you. It was a great time to work at TruckNet. And that was the time when I have started to write tests for front-end components. I have started to use TDD to develop my front-end components, and where I have started to share this knowledge with everybody. Then I have been working at Dockler Holding, an enterprise company based at Luxembourg. And I have been there at staff engineer role, and there I have continued to learn everybody how to write the tests in the correct way. And I believe I have played a big part in popularizing the testing library and making the tests in the company much better. And I know that there are also people from Dockler Holding. So hello, everybody. I'm missing you. It was a great time working at Dockler Holding. And right now I work as staff engineer and tech lead at Intuit. And I want to speak some words about Intuit because nevertheless, it's a large American-based software development company. It's not so well known in Israel. And I believe it's one of the best places in Israel to work because of the technical challenges. For example, in Intuit, we have QuickBooks Online, a large enterprise accounting software, completely web-based, working in your browser. And it is separated to more than 600 micro frontends, each of which has its own business context. And I can say that working in such separated environment have changed my life forever. Also, Intuit has won Company of the Year on the Glassdoor.com website, which gathers anonymous reviews from the workers. And I can definitely say that that's the best company to work in I have ever worked. But enough about myself and about the company I'm working in. Let's go straight to the point. So today we will speak about testing. We'll speak only about unit and integration tests. I really love end-to-end tests. I really love Cypress, but it's out of the context of today's discussion. And today's workshop will consist of 3 parts. The first part is the introduction, the problem statement. Then we will go to the main part, and then we will summarize everything we have learned today. The main part itself is separated to 3 different ingredients, how to write the test in a reliable way. And this will be an interactive sections where we will have some Zoom polls. I will ask you questions, you will need to answer them, so watch carefully. And also after each of the 3 ingredients we will have a special Q&A section where you have a chance to ask your questions. You can ask your questions in the chat, you can ask them verbally by unmuting yourself. I will be happy to answer all of them. So prepare your questions, you will have a perfect time to ask them. Also, before starting, I want to target my audience. If you're writing front-end code, and if you have started or thinking to start writing unit integration tests, you are a perfect audience of this workshop. Nevertheless, all the examples during the workshop are written in React. Everything that I speak about is completely framework agnostic. You'll be able to use your knowledge received during today's workshop with Angular, with Vue.js, with Sveto, with anything, even with just vanilla JavaScript. So let's start with the beginning. And the problem that I have stated is following. We all write tests, but most of us hate it. Like most of us works in large enterprise software development companies where tests are required. And usually there are some test coverage thresholds that force developers to write tests. And because of that, many developers really hate them because they believe that they make their everyday life much more difficult. When you need to do a change, you need to also change the test. When you develop a new feature, you need to develop the test. But I believe the tests are not the problem themselves. The problem is how people write them. And if you learn how to write them in a proper way, you'll get a lot of additional benefits that will help you and not your manager who forces you to do it. You specifically in your everyday routine. So let's speak about what will a proper test suite provide you with. First thing first is work and life balance. I know it's a generic phrase. Everybody hates it. I also hate it. But the idea is that if you have a proper test suite in your project, you'll be much less frequently be waking up in the middle of the night because of a production bug or something. Like, think about it. If you have a bug, if you don't have a proper test suite, you will not be able to reproduce it with the test. But if you have a proper test suite already, you'll be able to reproduce it with the test. And this way you will fix it much more faster. And also you will be confident that no regressions will happen. And that means that you will be waking up in the middle of the night because you're on call right now much less often. Ability to experiment and refactor. That's my favorite. If you have a proper test suite, you have a really great chance to check that something you have done is properly working with a single push of a button. What does it mean? It means that you'll be able to refactor your pull requests right after finishing them. Think about it. When you start to develop a feature, you always know less than when you finish developing it. So it's logical to me that after you finish your pull request, it's a perfect time to refactor it because right now you know everything. You know how to do it much better. But nobody is doing that because nobody writes like really good tests, which will not be broken during those refactorings. And that makes the refactoring process much heavy because you need to recheck manually after everything you do. But if you have a proper test suite, you can refactor it, push a button, be confident that it's still working. And this way you will decrease the technical debt in the future. Collaboration integrity. If you work in a large company, you always need not only to work in your repository, but also in repositories of other teams. And if this team has a proper test suite, it will be much faster to merge those pull requests because of two things. First one, the owner of the repository will be sure that no regressions are created and that everything which is already done in this repository is working good because he has a proper test suite. Also, he'll be able to review your newly added tests and be confident about the change you are doing. So this way, the process of merging pull requests to some other teams will be much faster, making the overall software development process much faster. And development speed. I know, most of you will tell me that when you write with the test, it takes much more time than it takes without them. But you know, it's like in sports. For example, if I come to you right now and ask you to run a 20 kilometers marathon, you will tell me like, no way, it will take me a year to learn myself how to run it. But if you're already trained and I will come to you and ask you to run like a 20 kilometers marathon, you will tell me, easy peasy lemon squeezy. The same goes with testing. If you start to write tests, if you learn yourself how to write them properly, if you gain those training muscles, as I call them, you'll be able to work with the test much faster than you work without them. And I cannot tell you that it will happen tomorrow. No, nothing comes so easy, friends. It will take like half a year, maybe a year, maybe a year and a half. But after you progress to this step, it will boost your professional career. It will take you to another level of software development, making your overall development process much faster, much more fun. So I believe it's a good investment for your future. So when there is a not like when you have just tests in your project, like not written properly, you'll be always failing to the same situation. You'll be every day standing on the same rake again and again because you have the same regression bugs happening every day. You cannot process, your technical debt is so big. And only by writing a proper test suite, you can make your process much more reliable. And if that's not enough for you, I have the final statement. Humans are bad at performing long and repetitive tasks. So let's leave those to the machines. I see ourselves right now standing in the very start of the new era, of the era when all the software is checked by the machines, not humans. And it's not future, you know, it's already started like 5-10 years ago. And it's your perfect chance right now to catch this train before it's too late and to start use those machines to make your development process much more easier. Okay, enough with the introduction. I want to move to the main part about the 3 ingredients to write a reliable test. But before doing that, I want to introduce you to this guy. His name is Ken C. Dodds, and he's a popular author who writes a lot about the JavaScript testing. I have started to read his blog like 4 years ago, and he's an author of Testing Library, which we'll speak a little bit later. And he has a paid course of JavaScript testing, which I suggest to everybody who are starting this journey. Or you can just subscribe to his blog because he always writes really interesting stuff about JavaScript testing in general and about JavaScript world. And I want to provide you with one quote of him. The more your tests resemble the way your software is used, the more confidence they can give you. And that is like my life credo about JavaScript testing. This idea will be connected to all 3 ingredients. And if you understand this idea that your test need to use your software absolutely the same way as user does it, it will make your test to last and to be reliable. And let's switch to the main part finally. 3 ingredients for a reliable test. And starting with the first ingredient, use less mocks. Simple as that. You can see that's like a regular test of a React component found somewhere in my company. And as you can see, there are a lot of mocks in the very start of the test. And that's how unit tests are usually written. When you write a unit test, you need to test your module in perfect isolation. So it means you need to unit test everything. But there is one problem with unit tests. When you mock something, you're always making a trade-off. Remember the quote from Ken C. Dodds? We need to reassemble the way the software is used by the real user. When the software is used by the real user, there are no mocks, right? And take a look at this funny GIF. It represents a software called Human Body. And developers of this software project did a really great job. They have written really great unit tests that test each of the models of the software independently in a perfect isolation. And they are sure that each model works absolutely as expected. And they're right. But the problem here is that there are no integration tests and nobody have checked that everything works together in integration. And as you can see, I cannot tell that this software is really working, right? And that's the problem. When you write only unit tests, it doesn't give you any confidence that everything works together. But why do we use unit tests? Why don't we use integration tests? There are historical reasons for that. In the backend world, people usually write unit tests because they are much more faster to be run and to be developed. because in the backend world, when you write an integration test, you need to bootstrap and tear down the database, the queue, something else, and that takes some time. So usually on the backend, people writing a lot of unit tests and a little bit amount of integration tests. But it doesn't work so good with the front end, because on the front end, there are no databases. There is nothing to bootstrap during your integration test. And everything you need to mock during your integration test is just the HTTP layer, which is cheap to mock. And what I want to say is that on the front end, you do not have so many reasons to write unit tests. You can always write integration tests to be much more confident about your software and to work much more efficiently. But the thing here that you cannot reduce all the mocks. It's not possible, seriously. And the true mastery here is to learn which mocks you need to use and which mocks you can get rid of. And because of this, I have prepared a special quiz. And it will be a simple quiz from now on. You have only yes or no questions. For example, that's a first example of a mock from our application where a Redux store is being mocked inside the test suite by a special Redux mock store package. I'm launching the poll right now, and I will give you like half a minute of time to answer this question. And the question is simple. What do you think? Is it okay to mock Redux store in a generic application or not? I will give like a minute of time to think, so don't worry, you have time. Ten seconds left. Okay, 3, 2, 1. And here we are. I see that most of you has chosen no, and that's a correct answer. Because remember the quote from Ken Seedorf, the more it reassembles the way the software is used in the real application, more confidence you get. And here's the thing, in the real application, not a mock store is used, a real store is used. And to speak frankly, there is no reason to use like a special mock store there. You can just use the same store you use in the real production application to receive much more confidence. Let's go to the second question. Here you see a logger, just a generic utility, you know, to write logs, like to write them in the console and to send them to a third-party server. What do you think? Speaking generally, is it okay to mock logger or not? Okay, 5 seconds left. 3, 2, 1. Here we go. So most of you has chosen yes, and that's the correct answer. Why I'm really happy that everybody is choosing the correct answers. And the thing is that it's absolutely okay to mock logger. Logger is not something that is visible for your end user, so we do not worry about it here. Also, we do not want any third-party network request to be called during your test suite. And also, by mocking a logger, you can provide a spy function to check if the logger has been called during your component render to be sure that all the logging works as expected. And that's what I usually do. The next question, is it okay to mock global variables available at production environment? Like in big applications, usually there is some special context object somewhere in a window, for example, or available somehow, like in another way, doesn't matter. And what do you think? Is it okay to provide a mock for such global environment in your test suite? The poll has started. And we're finishing the poll in 3, 2, 1. Okay, most of you has chosen no. And that's an incorrect answer. The correct answer is yes, just because of a simple reason. You cannot like work otherwise. If you use this global variable inside your code, then anyway, you need to provide this global variable inside your test. Like there is no other way how it will work. Otherwise, your test will fail. And that's one of the examples when you cannot live without a mock, okay? And the next question is it okay to mock fetch? And we have like 3 different options to choose from. So choose carefully. And on the screenshot, of course, you see a test which mocks fetch to return some fake network response inside the test to test that the code is working. Okay, and I'm finishing the poll in 5, 4, 3, 2, 1. Where's my mouse? Here it is. Okay, and most of you has chosen not so bad, but there is a better solution, and you're absolutely right. Like, anyway, you need to mock your network requests inside your tests because you do not want the real network request to be called from inside your unit on the integration test, right? But there is one interesting thing here that mocking fetch is not the best option because there are special libraries to provide a network mock on the HTTP level. For example, MSW or NOC. And by doing this mock, you'll be much more safe than by doing a just mock like here. For example, like during my professional career, I have seen one example when a developer has used a date object inside this fetch mock. And a real fetch will never return you a date object. It will return you a string, right? So his test was written incorrectly because of this incorrect mock. And his test was passing, but the software itself wasn't working at all. So it was like a false positive test. By using those HTTP level mock libraries, you'll be able to provide your mock and it will work absolutely the same as the real network request works in the real browser. Also, this MSW library works in storybooks and it also works in your production application. So by providing this mock, you'll be able also to use it inside your storybooks. And even to solve one situation when the backend is not ready yet, but frontend guys wants to start working on the feature, and they can use this MSW to write a single mock, which will help them to develop the feature on the staging environment, which will help them to create a storybook for the component, and which will help them to write an integration test. Like you kill 3 birds, not even 2 birds with 1 stone, guys. So I suggest everybody to take a look at this MSW library. There is also an NOC library spelled as NOCK, but it's less interesting because it cannot be used in storybooks and in your real production code. And to use those mocks is pretty easy. You just define that, for example, for the GET request to this URL, you return this JSON. And then inside your test, you just use server use to tell the MSW which mock to use. And all the network requests which are being made to this URL inside the test will be automatically mocked. Simple as that. And the last question for this section. Is it okay to mock a business logic service? Like usually business logic is written in a separate business logic service. And those business logic services are usually mocked inside React component tests, right? So what do you think? Like, is it okay to mock it or not? And I'm finishing the poll in 3, 2, 1. Most of you has chosen no, and that's the correct answer. I know that a lot of people have seen examples of such mocks across their code bases, but that's just because like back in the time, it was the only way how to do that. Because the component uses the service, which creates a network call, and you do not want your network calls to be made from inside the test. But remember what I was saying about MSW, and think that your business logic service can provide such network mock on the global level. And then you'll be able to take this mock and use it not only in the business logic service test itself, but also in your React component test to make it not to do any network request. And only by doing this, you'll be sure that your React component is integrated to the business logic service in the correct way, and that there are no like pitfalls in between. And I believe most of you know that there are a lot of bugs usually happening on the integration side, on the integration between React and a business logic service. And by using those HTTP mocks instead of your business logic service mocks, you will be absolutely sure that you do not have such bugs. So instead of this, you can just use a network mock, and that's it. So to summarize, you do not need to mock Redux store. You do not need to use shell rendering. It's not a mock, and we'll speak about it a little bit later. You do not need to use fetch mocks, but instead you use HTTP level mocks such as NOC or MSW. You can mock animation libraries. I didn't mention that in the practical questions section, but if you have some animation libraries which use JavaScript to render animations, you can mock them inside your test just to make them to run faster. You know, not to wait for those animations to complete before testing something. I believe that's like a good example of things that is okay to mock. Logger mocks, as we said, and production environment mocks, like global context or whatsoever. So remember, mocking is always a trade-off between confidence and speed of test execution. So reduce the number of your mocks to be much more confident in your tests. And here comes the questions section. And I'm opening chat right now. Why do we call end-to-end as integration test? It depends, because in different companies, like this separation, this classification is really different. And for example, at Intuit, also the Cypress test, the one that I call end-to-end are called integration, because they check the integration between backend and frontend. But it's more common to call Cypress test as end-to-end and to call integration test within one project as integration test. And that's the terminology that usually Dots stick to. So I use it like because everything that I speak about is based on his works. In Intuit, in the project I'm working, where I'm the tech lead, we use integration tests mostly to test everything that we develop by using testing library from Dots. We'll speak about it. And also we are developing end-to-end Cypress tests to be sure that everything works in like perfect integration, because in Intuit we are working with micro frontends, and when you write an integration test, you anyway check everything inside your micro frontend, and only end-to-end test allows you to test the integration between those micro frontends. Unit test, there is a reason why it is recommended. Like this is a historical reason, as I previously mentioned, that on the backend, unit tests are much faster to run and integration tests are slow. And because of that, for example, Martin Fowler suggests you to write more unit tests and less integration tests. But on the front-end side, as I've already spoken, integration tests are not so slow. So I'd suggest, as Conceit Dots suggests you, to use integration tests. Okay, I believe. In your opinion, the reason is historical. It's my opinion. Is not historical. It depends, because if you, for example, test just a business logic function, just a pure function, it's absolutely okay to write a unit test. It's easier to write, it's faster to maintain it. But if you go only with unit tests, you will not be confident that everything works in integration. That's like my point of view. So I do not tell you not to write unit tests at all. I just tell you to, to change the balance, to write more integration and less unit. That's it. About a specific website and course, I will be able to share an email with some interesting videos and materials, like reading materials, so you'll be able to check. But in general, Conceit.'s blog is an awesome place. And his testingjavascript.com is an awesome course, but it costs money. If you do integration testing, there is a need for unit testing only for pure functions, the one that doesn't have any dependencies at all. That's the only case, I believe. And to test subscriptions WebSockets is an interesting question. How I was doing it, I was mocking the socket.io library and providing some mock response values. I do not know if there are some libraries which will mock WebSockets on the HTTP level, because MSW, as far as I remember, does not do it. So the only thing is just to mock your socket.io library or any other library that you use with your WebSockets. I believe I have answered the question, Ray, about like, do we need integration testing if there is if there is a need for unit testing, if you do integration testing. My opinion that some of the functions are pure, and anyway, you will test them with a unit test because they do not have dependencies. And that's like the only exception. What do you do when you have a service that requires other services to initiate? That's like a great question. But if you will not use any business logic service mocks, there is no problem at all. Because anyway, if your service initiate another service, it will work absolutely the same inside your test. And you have provided the network mocks for both of the services. So everything will work like out of the box. Did I answer your question? So maybe I didn't understand it. Like, there are like different ways like how to initiate services, right? Okay, so if you have a class with the constructor that have multiple arguments for the constructor that accept other services, and if you are writing a test for this specific service, why not to use a real service inside your test and not a mocked one to initiate it, if we're speaking about integration tests. But anyway, speaking about your question, I'm thinking maybe in this case, when you have such like separated fashion, it's okay to write unit tests, because if you will not mock them, and if you use dependency injection, then I believe it will be like much better for you to write mocks for them, because this way, only this way, you'll be testing only the logic of this service. So yes, Ray, speaking about your first question, yeah, there are some cases for unit tests in front-end development also. And there was also a question from DZZK. So what do you call an end-to-end in such case? I call an end-to-end like a Cypress test, for example, which launches the Rio browser, and runs the test within this Rio browser. What I call unit and integration tests, they run inside Jest. They run inside a special JSDOM library, which is just a simulation of the browser written in pure JavaScript. And that's the biggest difference between end-to-end and unit integration tests for me. Oh, what do you do when you need end-to-end test, but without services available at end-to-end runtime? That's a great question, Ray, because actually we have been in such situation like today. And to speak frankly, of course, if you have those situations really often, of course, you can provide a network mock. You can reuse the same MSW mocks you have already written for your integration test inside your end-to-end test, inside your Cypress tests. But I do not like this approach, because when I run end-to-end test, I want to be sure that the integration between backend and frontend is really works like well, and that the backend has not been updated without letting you know. And when we have such problems, we just wait for the problems, to repair. But if you have microservices architecture, still you have like a staging server where all the microservices are always live. So you'll be able, like, without staging. In this case, you need MSW mocks inside your end-to-end test suite, or other HTTP level mocks. Like most of the end-to-end tools, like Cypress, for example, they provide a way to mock network calls. Okay, I believe that's enough for the first ingredient, and let's move on, and we'll have another Q&A section in the next section. And the second ingredient is do not test implementation details. And I believe that the most important ingredient that I will teach you today. But before like speaking about implementation details, let's make sure that everybody are on the same page. I want to introduce some vocabulary. Sorry, it's hard to speak so much during 1 hour. So implementation details are things which users of your code will not typically use, see, or even know about. For example, you have an application, and if, for example, you will change the way how the data is fetched on the component level or on the business logic level, that's an implementation detail change, because nothing is changed for the user. Or, for example, you want to change composition of your React components. For example, you have right now a header component, and you want to divide it to 7 different components without changing the design itself. That's also an implementation detail. You have changed the code, but nothing is changed for the real user. Also, there is one more important term here, refactoring. And it is a process of changing the code without changing the product's functionality for the end user. And as you can see, those two terms are deeply coupled together. When you do refactoring, you change implementation details. Changing implementation details is refactoring by itself. So this is how you can easily understand is your test testing implementation details or not. You just think if you are able to change the component, to refactor the component, and your test will not fail, then your test is not testing implementation details. It's a really difficult topic on how to understand what is implementation detail and what is not, and how you can avoid it. So let's play another game. And I know the previous game was a little bit boring, so this game will be much more interesting. Instead of 2 options, we will have 4 options. Wow. And let's go on. And the first question is following. How many examples of implementation detail testing can you find? I know it's a little bit difficult right now, but after the first question, it will be easier and easier. And you see here a test of some estimates page. And you see that here they click a create button and they check that the routing has been changed. Simple as that. So let's count how many examples of implementation details testing you can find. And then I will give you the correct answer and I will teach you how to find those implementation details examples inside your test. And I will give you a little bit more time because I know this question is much more difficult than the previous one. "30 seconds left. "15 seconds left. 5, 4, 3, 2, 1. And I'm finishing the poll. And let's wait with the correct answer. Most of you have answered 2. Let's count them together. The first one is here. What is done here in the test that the create button is found by its class name. And that's an implementation detail because the class name of the create button can be changed in any given moment of time in the future. The second implementation detail example is here. Instead of firing a JavaScript click event, the onClick function taken from the props is being manually called inside your test suite. And you know that when a button is pressed by a real user in the browser, he doesn't call the onClick function. He clicks a button. He initiates the JavaScript event. So that's also an implementation detail, and also the onClick function can be changed. I know that in most of the time it's called onClick, but still, like theoretically, it can be changed. And the third implementation detail example is here. They are checking the navigate spy function to check that a redirect really happened. But what's important here is that I do not blame developer for testing those implementation details. He's not guilty at all. The problem is that he has used enzymi or enzymi, I don't know how to spell it, sorry, library to write his tests. And enzymi is a great library, don't take me wrong. But the problem that it has been developed in 2012, I believe, by Airbnb team, and it was a long time ago, and it's already been deprecated in 2020, and today we're in 2021. No, 22. This world is spinning so fast, guys. And the problem with enzymi is that it enforces developer to test implementation details because it does not provide any tools to test it otherwise. So if you use enzymi, you have just no other options than to test those implementation details. But remember can see dots from the start of the main part. He's the author of testing library, and the basement of this library is providing a way to test components without testing implementation details and to enforce developers to use their tests, to use their code inside their tests the same way as user does. And let's take a look how this test has been refactored. Like instead of finding the button by its class name, it queries it by the text, the same way user does it. Because when user is looking at the interface, he finds for the text with his eyes, right? He clicks on the text, not on the class name. Then instead of manually calling this onClick function, we can simulate a real JavaScript event for this button. So it will work absolutely the same as it works in the real browser. And if onClick function will be renamed tomorrow, nothing is being broken. But the third example of implementation detail is left here because there is no other way. And that's the thing here, that of course you need to avoid testing implementation details, but sometimes you are not able to, and that's absolutely fine. You just need to minimize the amount of implementation details testing in your test suite. Because here in Intuit, we use always this navigate function provided by some global sandbox. And in the test, it's being mocked. So nothing is really run. So the only way to check that the redirect has happened is to check this spy. No other way, you know. And let's go to the second question. And I believe you have much more details right now to answer it. And that's the test of the same estimates page. But what it does, it searches for the pagination control component, which is pagination, and it checks its props to verify that the numbers are displayed correctly. How many examples of implementation details testing you can find here? And take into consideration that I count the repetitive examples. Like here you have some of the implementation details testing which are repeated, so count them all together. And 15 seconds left. Don't worry, you have 15 seconds more. 5, 4, 3, 2, 1. Okay, here we are. I'm ending the poll. And most of you have answered 4, and that's the correct answer. And you know, that game is pretty easy with NZME tests. After the component is being rendered, each of the line is implementation detail testing. So let's count them together. Like the first implementation detail example here is that we search for the component by its class name. And of course, it can be changed. You can change the composition of your React components. So it's not bulletproof to search for it this way. Also, you have 3 examples of those props checks. And you know, when your user uses your software, he never looks at your props in your React development console or something. He looks at the interface, he reads the text. So let's take a look how this NZME test has been refactored with testing library. Simple as that. It just renders the component and it checks that the correct text is being rendered on the page. And that's what you want to check. You know, this test is even more readable. And of course, it's much more reliable in the long run. What about more complicated examples? Because, you know, everything is easy with those easy questions, but in reality, we have much more complicated software. And take a look at the same test of the same estimates page. Here, what it does, it clicks on the next button of the pagination control. Then it waits for 10 milliseconds of time. And I can say that if you need to do something like that in your test, it's always a bad smell. I do not say never do this, but if you do this, always think maybe there is a better way because it just smells bad, you know? Then they need to wait for the component to refresh. And what they do here, they access a special instance variable of the component to await for it. And of course, that's like a huge implementation detail. This refresh promise can be renamed, it can be taken out easily, and etc. and etc. And then they check that the estimates business logic service function has been called with a proper argument. And then they check how interface has been updated. So what the biggest question for me is how to wait for the interface to be updated. Because you see here they're awaiting the refresh promise, but how can we do it otherwise? And in the testing library, you'll find everything you need. Take a look. What do we do here? We just click on the next button by searching for it by text. Then we provide a special network mock, which returns the second page of the invoices. And inside this mock, there is an if statement that if row index is not 10, then it returns an error. This way, we will be sure that the real backend API has been called with the corresponding query parameter and that we don't have a bug here. And then we need to wait for the refresh promise. Remember how usually user waits for the loading to be completed? He looks at the interface of your software, and there is usually a loading indicator there. And when the loading indicator disappears, it means that the loading has been finished, right? And testing library provides a special helper method called wait for element to be removed. So I believe it's pretty self-explanatory. It waits for the loading indicator to be removed from the page. But loading indicator is usually not a text. There is nothing like being written there, right? It's usually some icon, some loading animation, something. So you cannot search for it by text. What you can do instead, you can provide a special area label attribute to your loading indicator, and you will kill two birds with one stone. First of all, this area label helps users which cannot see your website, which have some visibility problems, to use your website with a special screen reader. So when he focuses on the loading indicator, the screen reader will read for him like loading, and he will know that something is loading right now, and you will make your website much more accessible. Also, you'll be able to search for such element by the special area label attribute, and testing library have a special query by label text helper, which search for this label text. So you will be able to find this loading indicator and to wait for it to disappear. And right after it disappears, you can check your interface that the corresponding numbers has been rendered. Also, I have seen so many times how people are setting state inside their test and then they check that something has happened. But you know, when your user uses your software, he doesn't change the state of components. And to speak frankly, like this test is even harmless, is even harmful, because it doesn't actually check something. What it does, it just sets the corresponding state and checks that something is rendered, but that's like will not provide you with any confidence. What you can do instead of setting states to simulate different use cases, you can use your network mocks, and that's why they're so important. So just use a corresponding network mock, which reproduce a special use case of your application, and check that your component works as expected. And what about show rendering? Remember, I was saying that never use show rendering. Why people use show rendering in the first place? Because it's much faster to be run. For example, this test written with show rendering takes 3 milliseconds of time to be run. And the same test, which doesn't use show rendering, takes 86 milliseconds of time. And you can tell me, like, come on, Alex, like show renderings makes your test to run like 30 times faster. Wow, so cool. But guys, you're not working in Python where tests are immediate to run. You're working in JavaScript. And you anyway have just test runner, which takes something like 5 to 8 seconds just to bootstrap. So anyway, when you run your test, you first wait for 5 seconds, and only then you will run your actual test. So I believe that difference, like 3 milliseconds or 86 milliseconds, doesn't change anything at all. And I believe those show rendering tests are harmful. So to summarize, how to avoid testing implementation details. You never access component instance. You never use component or props to query an element inside the component. You never access component props. You never access or modify component state. And you never use show rendering. Instead, you can search for the elements inside your components by text. You can search for them by ARIA label. You can search for them by input label. The query by label text helper method from testing library also helps you to find input by its label, which is usually a separate HTML element. In the really rare scenarios where there is no text and you cannot add an area label attribute, it's okay to use test IDs. Absolutely okay, and testing library provides a special helper method to search by test IDs. Also, you need to fire JavaScript events instead of calling functions directly. And you need to write your expectations based on UI elements and not on some intermediate values. So make your tests free of implementation details and refactor friendly. So the bottom line is simple. If you have written a test and you can refactor your component, your model, your service without changing the test, this test is free of implementation details. That's like an easy check. And just a funny meme that I have found in the internet. Like you see like Barney from How I Met Your Mother, which says, could snapshot test be any more coupled to implementation details? And that's what I do not like about like snapshot tests. It, like for me, snapshot test doesn't help you at all, because usually developers do not read what have been changed in those snapshots. Like you change your code every day. Those snapshot tests are changed every day. So after like 1 week, 1 month, half a year working, you'll always be skipping those snapshots because, you know, okay, I have changed something, something have changed in snapshots, it's okay. And they do not provide you with some confidence. The only exception, as for me, to use snapshot test, if you have a library of components, for example, and you need to be sure that the output of your library has not changed during the development. And the question section. We have only 15 minutes left and I need 10 minutes to finish the workshop. So we have only something like 5 minutes for your questions. How many assertions you recommend for each test? Like, hard to say, seriously. In general, I cannot say that there is some magic number. No, like it can be 1 assertion, it can be 10, absolutely okay. But what is important here that each of your tests should test only 1 use case and it should be isolated. So the order of the tests should never be important. Like you should be able always to shuffle your tests and they should continue to work. But about assertions, write them as many as you want. Like, for example, if you have a test which tests like 6 different numbers, but that's one use case, for example, to check if the numbers are not rounded. Okay, check all 6 numbers in one test. It's one use case. Should the design be tested as well? A perfect question. And I believe that the first example is when you need to test the active states. For example, you need to be sure that this button, if it was pressed, it has become active. It's a design thing. It can be checked by the class name, by the way. Yes, it's an implementation detail, but you know, the world is not black and white. So you need to check somehow for an active state. And to check button colors, it's really difficult inside the integration test because the tests are rendered in JS DOM, which does not render the real colors, the real CSS inside your test. So you can write assertion that the color is red, for example. You can just check the class name. So I believe there is no way, but you can use end-to-end tests to check the colors, I believe. Should we assert that something is not happening before we assert it's happened? And yep, and that's a good example. For example, you have a test which checks that something is being rendered after some click, and that's a good thing to check before that it didn't render before. That makes your test much more bulletproof. And in testing library, there is a special where it is, query by helper method, which helps you to write queries for an element that do not exist on the screen. You can use attributes to test active state. That's a correct suggestion, and I really like it. Yep. If you have some disabled attribute, HTML attribute, or class attribute, or any other attribute like data active, for example, yep, you can use it. For testing design, there are services out there that do visual assertions. One of them is API tools. That's maybe a great thing to check inside our team to run like visual comparison of the screenshots taken during the Cypress test run. We use Aaa strategy for test. As a result, there are some duplication for each test. I recommend extract some preparation to before each or stuff like that. First of all, the Aaa strategy, which stands for I do not remember the first A, but the second one is act, arrange, act, and assert. Yeah, that's a perfect strategy, and I really like it, and we use it inside our team. It helps to separate the test code to be much more readable. And yep, of course, if you have some blocks of code that you want to reuse, you can put them in before each. But also remember that do not repeat yourself principle doesn't work so good with the tests. Inside the test, sometimes it's better even to repeat the code. It's not production code anyway. It doesn't affect your bundle size or something to make it more readable. But if like every of your tests have the same preparation, like for example, network mocks, of course, move them to before each, because you know that this is this use case. You have 5 different states tests for this use case, and you can write the arrange inside the before each for all of them, not to repeat it over and over again. And we don't have any more questions, but just to mention that there are really a lot of different functions in the testing library. They have 6 different functions families, such as get by, query by, find by, and also get all by, query all by, find all by. And if you will learn and you will start using testing library, I really suggest to go to the documentation, and there is a special cheat sheet page there. Bookmark this page because it have like a table which clearly explains what is the difference between different functions in testing library, and it will help you in the start. And let's go to the third ingredient. Know what to test. Because not only writing the tests themselves is important, also you need to know when to write the test. And think less about the code you're testing and more about the use cases that code supports. Like in the perfect world, I want such tool as use case coverage, like test coverage, but use case coverage to test that all the use cases of the application has been done. But it's like in the perfect world, we do not have such tools, so you need to think manually and think always that your component have some different use cases, and you just need to check all of those use cases. You need not to worry about the test coverage itself, but about use cases coverage. And that's an example of two components. And that's how usually code is being separated in React. On the bottom, you see a banner component, which is a view component, like dump component, which doesn't contain any logic and just renders some HTML. And on the top, you see a write graphics banner container, which uses the banner container inside and provides some business logic integration. So what I want to say here, that you can completely skip testing of banner component because it's a dump component, it doesn't have any logic, and you can skip it absolutely. The top component is a container, a smart component, so that's the place where you write your tests. But then you come to me and ask me like, Alex, but my manager tells me that we need to have test coverage of 80%. And if I do not test my banner component, I will have much less test coverage. And that's not true. The thing is that if you write a test for write graphics banner container, and if it uses the banner inside, you will get a 100% coverage of banner component out of the write graphics banner container test. So test only the components which have some logics. But should I never test view components? I didn't tell you that. I tell you not to test components which doesn't have any logic. And here you see a split button, a view component. It's also a dump component, but it has a little bit of UI logic here. When this component is active, there is a special area pressed attribute. And I believe that's like a good example of an attribute to check for active states of buttons, as we have talked previously. And this logic should be checked, and it should be checked on the split button level, because you need to test the logic on the same level where the logic is written. And to understand this idea a little bit better, I have prepared not a game right now. It will not be interactive. Don't worry, we don't have enough time for that. But I will just tell you about some of the examples when you need to write test in a parent component or in a child component. That's the most common question I have heard. Like, take a look at this component. It is a registration form which uses a special input component inside. And we need to write a test to check if email validation function works correctly. So should we write it inside registration form, or should we write it inside input? The validate email function is implemented on the registration form level. So that's the place where to test it. You write a test for registration form component to check that this function works as expected. But what if you want to validate that a failed state is displayed properly when validation fails? The logic of the validation fails and the UI logic behind it, it's not in the registration form. It's inside input form and input component, sorry. So you should check that this logic works as expected, not on the registration form level, but on the children component level, on the input component level. Also, we have a more specific test to check if error is not shown when input is focused. That's usually how form behaves, right? You have an error, but if you focus on it, the error disappears. And also, you can check this logic from the registration form, but you should not do it because that's the logic of input component. So just test it on the input component level, and do not test it on registration form component because it's not connected. So to summarize, test only the component which contains some logic. And every component should test its business logic and not business logic of the inner component. Simple as that. Questions. Like I have like 2 more minutes if anybody will have any questions. Like the third section, I believe, is the simplest one, but still, I will wait for a minute. And then we will continue to the conclusion. What do you think about re-rendering a component in a test? Any use case? Yes, I believe there is a use case. And we, for example, had this use case in our team. We had a component which shows a tooltip only for 5 times. And it saves this information to the local storage of the browser. So 5 times it will be shown, on the 6th time it's not shown. And to test this functionality, like in the real integration fashion, what we have done, we have created a test that renders a component and then re-renders this component for 5 times and check each time that the tooltip has been rendered. And after the 6th time it is rendered, we check that the tooltip is not rendered. That's a perfect example of re-rendering inside the test. Okay, let's move on to the conclusion. To summarize, you need to use less mocks and avoid using unnecessary mocks. You need to mock network calls on the HTTP level with NOC or MSW libraries. You should use a real Redux store inside your test instead of using a mocked one. You should avoid implementation details testing, and that's the most important part here. That will save your life. So when you write a test, always ask yourself one simple question. Can a model be refactored without changing the test? And use a component the same way as user does it. This way you will be confident about your test. Sometimes you cannot avoid implementation details. That's kind of normal. The world is not black and white. Also, you need to know what to test, and you test only the components which contain some logic. And every component should test its own business logic and not business logic of the inner components. That's pretty it. If you have any questions, feel free to write in my LinkedIn. I was thinking to create a special Gitter chat for that, but to speak frankly, I do not use Gitter and I do not want to run another chat for those rare questions. So you can scan this QR code, add me in your LinkedIn, and feel free to ask. I'm always happy to answer your questions, seriously. Like, because of that, I'm testing enthusiast, right? And one last thing. I know writing proper test is hard at the start, but after you gain some muscles, your test you provide you with tons of confidence, boosting your career to a way new level. Thank you for watching this. I will share a special email with some materials to learn from tomorrow in the morning, also with the recording link, so you can share this wonderful workshop with all your friends who are interested in it and who were not able to participate it in live. But of course, they will miss the interactive part, you know. So it's always better to join like it in live.